Hello students, good morning guys, good morning everyone. Good morning and good morning. Like me and Shankar. This guys, uh, yeah, good morning Yogashri. Welcome back to the physics session and let us start. First few couple of minutes, let us try to revise what we have discussed in the previous session. Then we'll go ahead with a few more numericals now. As you know, this weekend portion is based on one-dimensional elastic collision and what is it perfectly elastic collision and inelastic collisions, one dimensional elastic and inelastic collisions. Already we have discussed about what is perfectly inelastic collision. uh, I mean uh, conceptual part. Now let us discuss some numericals based on this. In order to understand the how to in order to understand how to do the numericals, we have discussed one more additional concept called coefficient of restitution. Coefficient of restitution. The concept of coefficient of restitution is required for both what we call elastic and inelastic collisions. Okay. Now, so let us try to work out few more numericals, and whenever it is required, we'll try to look into some additional points or applications related to this again. Okay. Okay, guys. So in the previous session, we have discussed these points. How to find the total time taken by a ball to stop bouncing when you drop your body onto a surface. It is given by t is equal to square root of 2 h by g into 1 plus e by 1 minus e, 1 plus e by 1 minus e, and the total distance traveled by the ball before it stops bouncing is given by d is equal to h into 1 plus e square by 1 minus e square, where h is the height from which it is dropped and e is coefficient of restitution between the surfaces in contact. Here also h is the height from which the body is dropping, and e is coefficient of restitution between the surfaces in contact, and g is acceleration due to gravity, of course. And by making use of those points, we have worked out some questions, like question number 47. Okay. Now let us go through few more questions. Let us go through few more questions, guys. Question number 47, page number 47. Then question number 48. Question number 48. It is one of the previous year's JEE mains question. Actually, it is asked in 2008 to 2008 in engineering entrance exam. So what is given here is can understand what kind of questions are asking in the exams. Okay, it is mentioned that question number 48, page number 48. So I think this is guys, just point this just questions. Be careful about this one. Try to listen the question carefully and try to look into your volume. Just I'm following the neat volume. Okay, right. Better don't take this page number. You can note just go to this question where it comes in level 2. Level 2 question it is. Level 2 question. The question is: a ball is dropped from a height. A ball is dropped from a height h onto a floor of coefficient of restitution e. The total distance covered by the ball just before second hit is. Just before second hit is. Again, I am repeating the question. A ball is dropped from a height h. You can draw the pictorial representation of the given scenario. A ball, usually it will have some mass m. It is dropped means with initial velocity is 0 from height h. From height h onto a floor of coefficient of restitution e. The total distance covered by the ball just before second hit. First it comes here, travels through entire the distance equal to the height, then it hits first time. It hits first time. After first hit, it raises up with some velocity. Then it raises to a different height. It will be less than this. Usually we take this as a h1. It raises to a height h1. Then again stops and again retraces back and reaches the ground, and then it hits second time, then again it bounces up with some different velocity and raises to some height at h2. But the question here is, what is the total distance covered by it before second hit? Before the second hit means after coming here, first hit, what is the distance? Then plus, after first hit, it has traveled a distance of h1 plus h1 to h1. Then it undergoes second hit. So before second hit, the distance traveled is h plus to h1. What is this distance? We are asked to find. So the d is equal to the total distance. D is equal to h plus to h1. That's it. Already you have calculated what is the distance traveled by this body before it stops. Means infinite number of bounces or collisions it will take place. That we have discussed and derived the expression for this already. But we want now only this two. So how to consider this h in terms of h only you want if you see the options. So h, let us keep this h as it is, plus h1 2 into h1. Let us try to keep a substitute in terms of h, because we know that if you remember this relation, then no problem. Otherwise, you have to do what you call conventionally. We know that distance at the height raised during nth collision is equal to e power 2n into h. E power 2n into h. During after first collision, how much distance height it will raise is, okay, if you want, you have to use e power 2n. E power after first collision means n equal to 1. That means h1 is equal to, from this you can say h1 is equal to e power 2 into 1 is 2h. After second collision, how much height if you want? Here h2, then you have to substitute 2 into 2 becomes 4. So it is e power, what is that? 2h. E power 2h. So here h is common. You take this out, then we'll get h into 1 plus 2 e square. So this is the total distance traveled. So therefore, you can say d is equal to the total distance traveled before second collision or second hit is d is equal to h into 1 plus 2 e square. That's it. That's it. So which option? Look into that accordingly. Right. I hope it is clear, guys. Next. So right, let us see the next question. Maybe in the IET volume also the question number will be same. Question number 49. Go through that once. In level 2, exercise 1, level 2 exercise 1. Look into the question number 49. Okay. The question is, the question is, in two separate collisions, the coefficient of restitutions are E1 and E2, and they are in the ratio 3 is to 1. They are in the ratio 3 is to 1. Look into the question, guys. Look into the question in the volume. In the first collision, the relative velocity of approach is twice. In the first collision, the relative velocity of approach is twice the relative velocity of separation. Then the ratio between relative velocity of approach and relative velocity of separation in the second collision is. This is asked in 2007, guys, in one of the previous years in engineering exam only. Okay, fine. So what is given here? It is given that. In two separate collisions, coefficient of restitutions are E1 and E2, and they are in the ratio 3 is to 1. E1 by E2 is equal to 3 is to excuse me. Yeah, E1 by E2 equal to 3 is to 1 in different collisions. Two different collisions. In the first collision, what is given here is the first collision relative velocity of approach is twice the relative velocity of separation. Relative velocity of approach usually we consider it as u1 minus u2, right? u1 minus u2 is equal to twice the relative velocity of approach, 2 times v2 minus v1. Relative velocity of separation will be expressed as v2 minus v1. u1 minus v2 equal to 2 times v2 minus v1 in the first collision. Let us say this is in first collision. u1 minus u2 in first collision is equal to 2 into v2 minus v1 in first collision. Okay, then the ratio between relative velocity of approach and relative velocity of separation in second collision is, in second collision, what will be the ratio ratio between the relative velocity of approach u1 minus u2 in second collision, ratio between relative velocity of approach and relative velocity of separation. This ratio is how much? v2 minus v1 in second collision is how much is the question. We know that coefficient of restitution E is defined as relative velocity of separation v2 minus v1 divided by relative velocity of approach u1 minus u2 in general. Relative velocity of, this is in words you can write it as relative velocity of separation divided by relative velocity of approach. Relative velocity of approach. So now if you take this separately for first collision and second collision, for first collision you can take it as E1, second collision E2. So E1 by E2 can be taken as, for first collision it is V2 minus V1 by U1 minus U2 for first collision. V2 minus V1 for first collision by U1 minus U2 for first collision is E1. E2 is V2 minus V1 for second collision divided by U1 minus U2 for second collision. This is E2. Directly you can express them. So here this ratio is given as 3 is to 1. This is given and this relation is given here. So this further you can express it as in the next step. See here, E1 by E2 is 3 is to 1. Means 3 by 1. It is equal to, for first collision u1 minus u2 is equal to 2 times v2 minus v1. So we can write v2 minus v1 by u1 minus v2 is from this We want V2 minus V1 by U1 minus U2 for first collision. For first collision, V2 minus V1 by U1 minus U2 for first collision. We bring this here and if you send this 2 here, then we will get 1 by 2. So this you can replace. If you replace with 1 by 2, then you will get 1 by 2 into this this 1 U1 minus U2 divided by V2 minus V1 for second collision. You are asked to find what is this ratio. Simply send here this here, then you will get the ratio between relative velocity of approach and relative velocity of separation. The ratio between relative velocity of approach and relative velocity of separation in second collision is equal to, send this here, this 2 goes here, it becomes what it becomes 6 or 6 by 1, or you can say 6 is to 1. Got it? So here in the given options, option 4 will be the correct one. Different options are given. Option 4 is the correct one. So note down this quickly, everyone. Note down. Right. Next. Question number 50. So go to the next one. Yeah. So the next question is, a sphere of mass, you can take it as C, 50th one. A sphere of mass m moving with constant velocity u, a sphere of mass m moving with constant velocity u collides with another stationary sphere of same mass. Collides with another stationary sphere of mass of same mass. If E is the coefficient of restitution, the ratio of the final velocities of the first and second sphere is. So, it is mentioned that there is a sphere of mass here. There is a sphere of mass here. You can say this is m1 is equal to m. It is moving with a constant velocity u. It is moving with, say, let us say its initial velocity is u. And it collides with another stationary sphere of mass, same mass. Another, let us say m2, which is equal to same mass as that of this one. Same mass, and it is stationary. So by here by writing this is, looks and smaller and bigger, but be careful about that. Better to draw for understanding purpose only. Just you can consider this as this is m2 also equal to m, and it is what its initial velocity u2 is 0. It is mentioned that it is initially at rest. It collides with it collides with another stationary sphere. Stationary sphere means it is at rest. Stationary sphere of same mass. If E is coefficient of restitution during the collision, this is before collision. During collision, if they are in contact, then after collision, they may move with different velocities. Okay, they may move with different velocities. If E is coefficient of restitution, the ratio of the final velocities of first and second spheres are. First and second spheres are, if they are exactly elastic collision, if it is mentioned that this elastic collision, their velocities may interchange. But it is not mentioned. So be careful. You may ask, sir, you have already discussed under some special case that if the two equal masses are there and if one body collides with another, it becomes to rest. This may start moving like that. It is provided if it is perfectly elastic. But here it is not mentioned that. So let us say this is moving with velocity v1, this is moving with velocity v2. Then the ratio of final velocities of the first and second spheres. Final velocities of first and second spheres. What should be v1 and what should be v2? v1. You have to, by using what you call um, yeah, by using relative velocity relations, you can what you can understand here during a collision, relative velocity of separation by relative velocity of approach is coefficient of restitution, right? So in this case, if or you can by making use of the already calculated in any collision final velocities are given by v2 v1 v2 as we have discussed some derivations for those, right? v1 is equal to m1 minus m2 by m1 plus m2 into u1 plus 2m1 2m2 by m1 plus m2 into u2. Similarly v2 also I have discussed. So according to these expressions, also you can get the relations of v1 v2 and you can substitute, and according to this you can say what you are asked to find here. The if E is coefficient of restitution, the ratio of final velocities of the first and second collision, so it is obtained to be final velocities of first and second collision v1 by v2 is equal to what? Just like you can observe the velocity of a body after first collision. Velocities are different and the distances, once again, yeah, you used to get the expressions for these final velocities as by using those relations. Just I'm giving you directly here, but just try this once, guys. Then v1 as separately, if we take here v1 and v2 relations, v1 will be, what is that, m1 minus m2 in normal and in a collision, m1 minus m2 by total mass m1 plus m2 into initial velocity plus 2m2 by m1 plus m2 into u2. Similarly v2 is equal to m2 minus m1 by total mass, right, into u1 plus 2m1 by m1 plus m2 into u2, right? In these expressions, if you as per the condition of the given collisions, in these expressions as per the conditions of given collisions, if you substitute these values, you'll get the what you call the values of v1 v2. Actually here we are considering these collisions as inelastic collisions. Inelastic collisions we have discussed. In elastic collision, this actually for elastic collisions we have discussed. In case of inelastic collision, here because it is not mentioned that the collision is elastic, we have to substitute the values differently. Then I'm going to give you another set of values for v1 v2 here. These are for elastic collisions. For elastic collisions, but it is not mentioned those collisions are elastic. So for inelastic, if you consider for inelastic If it is elastic, surely, obviously, you get the option should be what is that ratio between the velocities will be as V2 will be U1 and V1 will be 0. The ratio will be V1 by V2 will be as it is 0, it will be 0 only. But you see here, you will not get such kind of option. So you have to understand that it is an inelastic collision. In case of inelastic collision, we have to remember that again, if you by the same procedure you have to use to derive this relation. V2, that is in case of elastic collision, we have got what is that? V2 minus V1 equal to U1 minus U2. I said that ratio is called a coefficient of restitution. But for any collision, you can say for any collision, we can say V2 minus V1 should be equal to E into U1 minus U2. For elastic collision, this will be equal to 1. That's what we have obtained the relation here. And by substituting for V2, then we will get V1, and if we substitute for V1, then we will get V2 in the law of conservation of momentum relations. Now here, if you substitute this in case of inelastic collisions by taking this E into consideration, then we will get different expressions for V1, V2. Those expressions try to keep in mind, guys. Everyone, V1 will be equal to M1 minus EM2 divided by total mass into U1 plus 1 plus E into M2 divided by total mass into U2. Similarly, V2 is equal to 1 plus E into the terms interchanges in elastic collision just like that. Oh, sorry, I think this I have written wrongly, guys. Here also. Sorry. No, not this way. The terms will interchanges. I told right. This will become 2m1 by total mass. Here it will becomes m2 minus m1 by total mass. This will be u1 term. This will be u2 term. Similarly, in place of 2, you will get here 1 plus e into 1 plus e into m. What is that? 1 plus e into m1 by total mass m1 plus m2 e into u1 plus m2 minus em1 m2 minus em1 divided by total mass into u2. This relation will get for v1 v2. Okay. So in this, as initial velocity of second body is 0 and the masses are equal, initial velocity is 0. These terms will become 0, right? This is what you have to just keep in mind. That's it. Then initial velocity of the second body is 0. Initial velocity of the second body is 0. If you substitute that this is 0 and this is 0, you get these terms. And if you take the ratio of this and by taking masses are equal, here masses are given as m1 is equal to m2 is equal to m, then you will get this ratio. So what you will get here is v1 by v2 is equal to m minus em. So as m is common, you can take this as m into 1 minus e by 2m into, of course, u1 divided by this becomes 1 plus e into m by 2m. So here 2m gets cancelled, m gets cancelled. What will you get? 1 minus e by 1 plus e. This is how you will get this one. Just try to keep this in mind. It's 1 minus e by 1 plus e. This is equal to 1 minus e by 1 plus e. Therefore, v1 by v2 is equal to 1 minus e by 1 plus e. Note down this, everyone. I have given you these relations directly, and that is by using this we'll get you have to keep this in mind. In case of inelastic collision, for inelastic collision. Right, next let us do few questions in level 2. Level 2. Go through level 2 questions. So the question number 15, level 2, it is given that it is based on elastic and inelastic conditions. The question is, a 16 gram mass is moving in the positive x direction at 30 centimeter per second, while your first body is u1 and the second body is u2. u1 is how much? 30 centimeter per second, but it is moving in positive x direction. So you can take like this. This is u2 is moving in the negative x direction, so you have to take this as u2 vector is minus 50 centimeters per second. The negative sign says that it is in vector form if you want, otherwise plus 30 I cap minus 50 j cap, minus 50 I cap only, minus I cap, that you can be expressed as minus 50 I cap or 50 minus I cap. So here that sign tells about the direction, okay, direction of motion. Then they collide head on and stick together. So one body M1 is moving in positive x direction, and M2 is moving in negative x direction. This is moving with velocity u1 and this is moving with velocity u2. And they collide head on. Then the common velocity after collision. It is mentioned that they stick together after collision and they will move. Okay, so because this is greater, it may move with maybe in this direction because it's greater velocity and greater momentum. So what is the common velocity? We know that according to law of conservation of momentum, m1 u1 plus m2 u2 is equal to m1 v1 plus m1 v2. If v1 and v2 are equal to v, so we can write as v is equal to m1 u1 plus m2 u2 divided by vector sum plus total mass m1 plus m2. So by considering this, you have to calculate this. So try to find out this. What did you get here? Right, m1 common velocity after collision is equal to m1 is 16. All are given in SIGS units only. 16 into u1 is 30. This is minus m2 is 4 into 50. 4 into 50 divided by total mass 16 plus 4 20 grams. 20 this is equal to, that's how much is this? 16 threes, this what 16 threes 48. Yes, so 480 minus 450 is 200 divided by 20. Total mass is 20. All are SIGS units. So you will get here 480 minus 200 is 280 by 20 plus 280 plus 280 by 20. So 0 cancel. You will get what do you get? His total mass is, they have given in SIGS units and SI units, both the option, both they have mentioned, guys. Try to observe this carefully. Right, these are centimeters per second, grams and centimeters per second they have mentioned. So if you take this, it will be 28 by 2. Of course it is equal to 14 centimeters per second, right? Centimeters per second. And if you convert this into meters per second, you can write it as 14 into centimeter is equal to 10 power minus 2 meter per second. So you can write it as 0.14 meter per second. So what is the right one? So 0.14 meter per second or 14 centimeter per second. So V can be 14 centimeter per second or 0.14 meter per second. In the options, you have to observe the units properly. 0.14 centimeters per second they have given. No, it is not wrong. It is not correct. It is wrong. 0.14 meter per second. This is the correct one. So take it accordingly. Take this accordingly. And similarly, you see here next 51. Right, level 2 guys, level 2. The question is, a bullet of mass 50 grams, a bullet of mass 50 grams going at a speed of 200 meter per second strikes a wooden block of mass, strikes a wooden block of mass 950 gram and gets embedded in it. The velocity of the block after impact is, the velocity of the block after impact is, a bullet of mass 50 grams is going at a speed of 200 meters per second, huge velocity. This is what you have to understand. So whether it will go and stop, or this will try to make that wooden block of 950 grams also to be moving with the common velocity, that you have to understand. So because it is moving with huge velocity, there is a possibility of this may after embedding into the wooden block may move along with. So to understand that, let us try to use what we call same law of conservation of momentum. A small bullet M1, it is hitting a wooden block, a huge one. It is moving with velocity u1. It is of course initially at rest. It strikes a wooden block, okay, and gets embedded into it. After collision, both these two will stuck together and they will be moving with a common velocity. M1 and M2 will be moving with a common velocity. What is that common velocity? We are asking to find. According to law of conservation of momentum, they have to say from law of conservation of momentum. From law of conservation of momentum, we have to say, we can say that m1 u1 plus m2 u2 is equal to m1v plus m2v, or m1 plus m2 into v. So from this we can say common velocity is v is equal to m1 u1 plus m2 u2 divided by total mass m1 plus m2. It is equal to m1 u1. U1 is here you can write m1 is equal to what? 50 grams, and m2 is equal to 950 grams, and u1 is 200 meter per second. This is given in SI units, and of course u2 you have to take it as 0. These are given in CGS units, this is given in SI units. So in the options also they have given in SI units. So based on the options we have to simplify. So because the options are given in SI units, convert this also into SI units and take here m1 50 gram. It can be expressed as 50 into 10 to the power minus 3 into u1 is 200 in SI units only, 200 meters per second, plus m2 u2 is 0. This term will become 0 divided by total mass. Total mass is 950 plus 50, 1000 gram is nothing but 1 kg. So on simplifying this further, we will get v is equal to what is this? For 50 into 200, you can write 5 into 2 into 10 power 3, 10 power plus 3, 10 power minus 3 gets cancelled, then 5 into 2 is 10. 5 into 2 is 10. So you get 10 meters per seconds. That's it. Simple. Direct. It's a direct one. Next, question number 52. Let us see what is given here in this question number 52. Question number 52, based on elastic collisions, one-dimensional elastic and inelastic collisions. What is given here? A block of mass 1 kg moving with a speed of 4 meter per second collides with another block of mass 2 kg which is at rest. If the lighter block comes to rest after collision, then the speed of the heavier bodies. The speed of the heavier bodies. Right. Question number 52. It is given that a block of mass 1 kg, let us say it is m1. Let us say it is m1 is equal to 1 kg, is moving with a speed of, initial speed u1 is equal to 4 meter per second, 4 meters per second, and it collides with another block of mass 2 kg, another block of mass 2 kg, which is at rest. So initial velocity of the second one is 0. If the lighter block comes to rest after collision, so this is the lighter block m1, it is a heavier block m2. So it is moving with velocity u1, this is at rest, u2 is 0. After hitting it, this comes to rest and it is moving. This comes to rest, v1 is 0 and it is moving with velocity v2. Then speed of the heavier body after collision is what? This is before collision, this is after collision. Okay, so after collision. So to understand this, let us apply law of conservation of momentum. We can say from law of conservation of momentum, you can say m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So here m1 u1, m1 is 1, both are in SI units, u1 is 4 plus m2 u2 is 0, so this is 0 is equal to m1 v1. This comes to rest. So here is also given that v1 is 0, then what will be v2 is the question. What is v2? So v1 is 0 means this term becomes 0 plus m2 is 2 into v2. So what is v2 then? 2v2 is 4, v2 is equal to 2 meters per second. 2 meters per second. That's it. See here, these are few questions based on elastic collision. Now we can try to work out few more questions based on elastic collisions, elastic and inelastic collisions. You see here the previous one, level 2 exercise 2 we did. Now level 2 exercise 1, few questions based on elastic and inelastic collisions. Level 2 only, but exercise 1, level 2 only, exercise 1. Question number 40. Question number 40 based on elastic and inelastic collisions. The question is, okay, from level 2, exercise 1. The question is, the body of mass 5 kg moving with a speed of 3 meter per second collides head on with a
head on with another body of mass 3 kg moving in the opposite direction at speed of 2 meters per second. The first body stops after the collision, the final velocity of the second. Here it is mentioned, if you observe the compare the previous question, here both bodies are moving in same direction, but here they are moving in opposite directions. They are moving in opposite directions. Then how we have to take the sign conventions of velocities? That is what you have to consider little carefully, and you have to work it out. So note down now. Try yourself. Right. So what is given here? A body of mass 5 kg. Let's say it is m1. m1 is equal to 5 kg, moving with a speed of 3 meters per second. Initial velocity of this is 3 meters per second. Collides head on with a body of mass m2, which is equal to 3 kg in the opposite direction at a speed of, means it is moving with the speed of 2 meters per second in opposite direction, means you have to take it as minus 2 meters per second in opposite direction. Negative sign tells about opposite direction. The first body stops after collision. That means final velocity of the first body is 0. Then the final velocity of the second body is v2 is equal to what? v2 is equal to what? So you have to this sign conventions you have to understand based on the direction of motion. Now to find this, let us see. Let us try to use what is that law of direction of momentum. The next one is also based on that. You have to just take it carefully, but with the sign conventions, with vector notation. In vector notation, I will take that. The next question in vector notation. So let us first finish this. From law of conservation of momentum, m1 u1 plus m2 v2, but in vector form I have to take, is equal to m1 v1 vector plus m2 v2 vector. So this gives you m1 5 into u1 vector. So it is moving in a particular direction. It is a positive x direction 3. Here m2 plus m2 is 3 into u2 is minus 2. So that means you can take it as minus I cap. This is I cap minus I cap. So we have to take it as minus 2. So vectors rotations, if we take the direction is important, then it is equal to m1 v1, it is 0, plus m2 v2. Okay. So now this is 5 3s 15 minus 6 is equal to m2 is what? 3 v2. So 15 minus 6 is 9 is equal to 3 v2. So v2 is 3 meters per second, plus or minus, plus. So v2 will move after collision, because second body is moving in negative x direction. After collision, it will move in the positive x direction. That's it. Okay guys, as time up, I'm winding the session now. So based on elastic and inelastic collisions, few more questions are there. Try to finish this today, and tomorrow just we'll try to discuss few more additional points in the next session. Okay, then take care everyone. Bye bye.